This is the phone I'm trying to use to control my garden and everything. And if you look right there, you can see that I have soldered two wires to these pins. You would see that there are some tags for each of these pins. For the two that I have soldered, you cannot see them, but they were labeled TX and RX. Obviously, that means this phone is capable of doing some kind of serial communication. This phone is able to make a serial communication, but only for 2 volts. So like the high is 2 volt and the ground obviously is low. Whereas any microcontroller I have like Arduino or ATtiny, then the 5 volt is high and 2 volt is not considered high, it's considered low. So no, any kind of communication can happen from the phone to the Arduino. But the opposite works fine. So from Arduino, the 5 volt, when delivered directly to this, supposed to lower it to 2 volt, but I didn't, and it worked anyway. So for that, I needed an op-amp or a way to amplify the signal going from my phone to my microcontroller. And I think it can be done with 2 transistors, but I am too beginner, so I use this quad op amp, which it's a waste of money. I know I could have done it better. Anyway, these 2 wires are for serial communication. I want to run my project on 5 volt, and I could have given the phone power through its USB port, but then the phone wouldn't work without a battery, so I would still have to provide a battery anyway, which is a waste. So I decided that I want to give power to the battery directly, so the phone always thinks it's running on battery. On another phone that I have used earlier, I tried to give it 5 volt directly and I have destroyed it, so I didn't want to take that risk again. So what I did here is connecting 2 diodes, one Schottky diode, and well, there is another diode here. I don't know if you can see it. So I connected these 2 diodes in serial, and that gave me a drop of roughly 0.8. Not only did I drop the voltage, but also I could use these as temperature sensor, because the amount of voltage that the diode drops depends on temperature. And if I can check from my phone how much battery level is there, then I could know how much did that diode drop in voltage, and from that I could calculate what is the ambient temperature where the phone is. Anyway, that's out of topic, but I thought it would be interesting. Now I have here the place where the Wi-Fi antenna is supposed to be, and I honestly am not sure what kind of antenna is supposed to be, so I just soldered a wire to it, and I'll figure out later what to do with it. Microcontroller that is going to communicate with it is going to be this one. So let's put the phone on the side. I'm using ATtiny right here. It's an 8-pin microprocessor. It's like Arduino, but it's only 8 pins. Of them, there are 2 pins for the power, so you're only left with 6 pins. And of these, there is one that basically allow you to reset the microcontroller for programming it. So it's difficult to use that one, so I end up with 5. I use 2 pins for communicating with my phone. It doesn't have a serial communication built in like Arduino, so yeah, I have to use a software one. And that leaves me with 3 pins. And I connected 2 pins to these 2 relays, so I could turn them on and off. And supposedly one of these relays would be connected to my electric valve for the water. And the other one, I think I would use it for light. Rest of the circuit is simple. These are just resistors for the op-amp. This is a capacitor, just because you should have a capacitor for your microcontroller. You can see it from the other side, just very simple soldering. Now this wire coming from here, it has one connection to the plus, one connection to the minus, and 2 connections to the serial ports. And well, it's a telephone line basically, and I want to be able to connect my phone here through a phone socket, and I'll be able to control it from here through the phone line. So yeah, can have some distance between them. because like I said, I wanted to use it as a webcam, so I want to be able to freely move it wherever I want. So I've placed my phone here inside this cheese. Now I have, these wires are going to be the two, the red and black are the power. The other two are for RX and TX. And I have placed this phone thing, the phone socket inside. I just cut it, and then I intend to put some glue around here, and then connect the wires to this, and that's it. I have a fully sealed phone box like that, and then that's my webcam. On the other side, I have made a hole for the camera, and I intend to put some transparent plastic here, and of course I will also put some glue to keep my phone in place. Now I intend to use hot glue because it's much easier to remove later if something goes wrong, but I'm a little bit concerned because this one will be outdoor and I'm not sure if the glue would melt. The phone is now connected with the phone socket and everything, and I think I am ready for one testing. I tried one time and I found that the phone didn't start, and after doing some checks, turns out that the voltage at the phone is 3.4, and as far as the phone is concerned, that's like a dead battery, and so it wouldn't start. And the reason for that is because the wire, that it didn't happen before, it was working fine before, and the reason for that because the phone wire had some resistance. It's roughly 14 ohm, and apparently that resistance added some voltage drop, and yeah, it became 3.4, which is too low for the phone to start. So what I did here is removing my Schottky diodes. Well, first thing I need to say that using diodes to drop voltage is kind of a hack, and it's not the professional way to do it. It's just because it's very cheap and I feel like I could get away with it. So I removed the Schottky diode from here, and now you can only see one diode, which is a normal 0.6, the normal diode, which normally drops 0.6 volt, well, more or less depending on temperature. And I'm ready to do another testing. So I tried to turn on my phone. It didn't work when I connected directly to the power without the phone line. It worked fine. I had to use my oscilloscope because the multimeter kept changing its reading. This is the signal I'm getting. The voltage is swinging between 2.8 volt and 3.7 and 2.8. And of course the reason why it's dropping is when the phone starts running, apparently it draws more power than what the wire is able to supply, and that's why it drops. So it shuts down and then it tries to start up again when the voltage is high, so it drops, and then the voltage go back high, so it tries to start up again, and so on. I already removed the Schottky diodes. It didn't help. I mean, probably it did, it improved it a little, but well, it's still not working. Now, earlier I said that this wire, this phone wire, had a 14 ohm resistance, and I thought, well, 14 ohm wouldn't be such a big deal. But then I realized it's not 14 ohm because I have two wires going, one for the positive and one for the negative, and so we add these two together and that's 28 ohm. It's taking too much of the voltage that the phone cannot start. I removed the diodes, all of them. I reduced the voltage a little bit to 4.9 just to reduce the risk of burning my phone. Now I see a flat signal on the screen, no more jumping, and the flat signal is at 4.7 volt, which is, well, roughly is the same as the input voltage. And the reason for that is that because the phone is not turning on at all. So now the phone is detecting that there is a 4.7 volt, and I think this is too much, so it's refusing to start from the beginning. Now obviously if I try to reduce that to 4.2, then I should start getting my phone working again, but then I would have the same problem like I had before. Actually no, let me reset. Let me disconnect and then reconnect the phone again. See if that helps. Now it's disconnected, now it's connected, and I can find, yeah, you see that? That's not good. So it's the same thing happening, only much faster now that I don't feel comfortable. Keep it. Alright, so here is the part that has been done so far. This is the wire coming from the AC. This is going to be my power supply. It's a USB charging circuit, which I lost its casing, and well, I made that casing for it. That's a 5-volt wire. Now it goes all the way to here, and this is like my electric hub. So many wires are going to come out of this one. These two wires here are going to a 6-volt battery, and we have a step-up circuit here which would raise the voltage and charge the battery, and then the battery will have two wires coming out of it, which I would use to turn on the solenoid. I just needed to give a lot of amps when I'm turning on my solenoid, that's all. The other wire is going here to this circuit, which contain my AT-Tiny and the solenoids. The other wire would be going to my phone. Originally the phone line here had 4 wires, 2 for serial and 2 for power. Now the 2 for power didn't work out, and I think I will want to reuse them for something else, like for example use stepper motor to move this so I can have a better view. But well, for now it's still providing power in addition to the normal wire. Right, on the other side here I have used a small piece of plastic to protect my phone's camera, and I glued it. As you can see, I also glued that one here, and yeah, I think we're ready to test it. So this time you can see that I'm getting a ping response from my phone. Yay! Alright, means everything is working fine. Now let's try to connect, and well, we're in. So I'm connecting to my phone through SSH, and I have a script that I could run to control the relays. So, well, let's see. Let me show you the script first, what it does. Not here, maybe. Oh, it's very responsive. I'm surprised that the antenna is working. Oh, it's very far from the access point. Alright, so this is my script. Now I start by saying input event 3. That's because when my phone starts, it starts the IP webcam, and it's in the foreground, and I would rather have it in the background to stop depleting my phone's battery. And then I use this STTY dev console. Now dev console is the one which output to the TX and RX pin on the phone. I'm trying to use a very low bandwidth. See here I'm using 4800. That's a very low bandwidth, so I'm trying to avoid any kind of noise. The trade-off for that is that the communication will be very slow, so after I send a command, maybe I have to wait a second or two before I send another one, or before even it take an effect, which is fine by me. And then I have devised some kind of protocol that both my phone and my AT-Tiny understand. So I say pin colon pin number, and then if I put after O, means I want this pin to be output pin. If I put H, then I want the pin to be high. If I put L, I want it to be low. And if I, instead of O, I make it I, then I can make it input pin. And if I put R, I get the reading for that pin. So that's a pretty simple protocol. And then it's just sleeping, turning the pin high, then sleeping again, turning the other pin, number 3. So this pin variable is 4. So this would turn 4 high, then wait, then turn the pin 3 high, which correspond to the two relays, then sleep, then turn the first one low, then sleep, then turn the other one low. Okay, and that would be repeated forever. So supposedly I should get the first relay on, the second relay on, then the first relay off, then the second relay off. That's just my test script. Now let's see if that would actually work or not. Let's just do that, sh, and we wait. Alright, so let's see if it's working or not. The first relay, 6 seconds later, the second one should turn on. And here it is, then the first one turns off. Then the second one turns off. Alright, and there we have it. Alright, so here is my final setup. This is my solenoid. Of course I will insulate these wires, but I'm just testing now. It's going to the battery. And then, yeah, you've seen everything. This is my phone, blah blah. And that's the electric plug. And this is bringing the water to that sprinkler over there. You can see here. And yeah, I put some weight just to keep it straight, and it should turn on. Let me go ahead, turn on the script and see if it would work or not. So I turned on the script, and as last time, the first relay should turn on, then the second one, then the first one should turn off. Oh, here's the first one, then the second one should turn off. Okay, that worked fine, I think. You can see, watering the garden and everything. Awesome. But now it should turn off. And it's not turning off. And what I think the problem is that this solenoid is drawing a lot of power from the charger, and my ATtiny has shut down, or my phone. So I'll have to disconnect the plug and probably add a resistance or something. I think adding a resistance should help. We'll see. So I added a 10 ohm resistor and it did the trick. See now? It's able to turn off and on again. And then off again. And that's that. I think I'm done here. I think my project is complete. I just need to seal it. And yeah, it's over. It's over for good. Thank you for watching.